Welcome to Ask and Learn.
We are given a non-deterministic finite-state automaton, and we are asked to find a deterministic finite-state automaton that recognizes the same language as the non-deterministic machine. The non-deterministic machine is the one from exercise 45 of the book. In that exercise, we determined that the language recognized by the machine was 0, 1 star, union with 0, 0 star, 1, 1 star, Now, to instruct the deterministic machine, let S0 be a start state. Now consider the empty string. The empty string should not be recognized by the machine. And therefore, it follows that S0 should not be a final state. Now, suppose that the first bit is a 0. And we see that 0 is recognized, it should be recognized by the machine, so we'll move to a final state. Call it S1. Now, if the next digit is a 1, then we'll remain at S1 because 0, 1, and in fact 0 followed by any sequence of 1s should be recognized. So suppose that the remaining string, or I guess I should just say the next bit, is a 1, and we're going to remain at S1. Suppose, however, that the second bit is a 0 instead. Then we see that 1 or 0, 0 should not be recognized. So we should move to a non-final state, call it S2. And we want to move back to S0 because that would imply that 0, 0, 0 would be accepted, which it should not be. So we need a new non-final state, S2. Now, suppose that the string is going to contain another 1. Then we're going to move from S2 to, and because such a string, if it contains at least one 1, should be recognized by the machine, we want to move to a final state. And this final state has to be yet another new state, S3. We can't move to S1 because that would imply that 0, 0, 1, 1, 0, 0, 1, and then 0, 1 would be accepted, but it should not be accepted. Otherwise, if the remaining string does not contain any 1, then remain at S2, since it's non-final. As this string should not be accepted. Now suppose that the input at state S3 is 1, we'll recall that to get to S3, the rest of the string had to be 0, 0, star, 1. So it follows that the string with another 1 should still be recognized, and therefore we'll want to remain at S3, which is already a final state. Otherwise, if the input at S3 is 0, well then the string should not be recognized. So we'll move to a non-final state. Which we'll call S4. And the reason this is a new non-final state instead of, say, S0 is because once we reach this point, the string can never be recognized. So we don't want it to ever be recognized. And after this, remain at S4 for any input. Now, suppose that the string at the very beginning starts with a 1. Then we see that the string should not be recognized, and so we want to move to a non-final state. And in fact, we see the string can never be recognized no matter what follows it. So we'll move to the non-final state S4. And then we see that we will remain at S4 for any input after this.